Hello grade 7. Today we're going to be starting lesson 6-8, parallel and perpendicular lines. So before we go any further, I want you to open up to textbook page 170 and 171. And if you haven't done so already, I want you to read over textbook page 170 and 171 to familiarize yourself with what it is I'm about to teach you. So pause this video now and please do so if you haven't already. Great. Okay, welcome back. So we're starting lesson 6-8. Parallel and perpendicular lines. As I go through these slides, you guys, I want you to pause at any point in order to take notes, add notes, whatever you need to do. The nice thing about a video, unlike the classroom, is that you can pause me at any point if you need more time to take notes. So please copy what you see on the screen now. Okay, and once you've done so, unpause, and then I'm going to walk you through what you see on the screen. So, okay, great. Up until now, all right, we've discussed linear equations. A linear equation is y equals mx plus b. It can be expressed in the name y equals mx plus b, right? Or it could also be expressed in point slope form, which is what we just learned about. Okay, standard form. But what makes a line linear is that this x here has 1 as an exponent. It's x to the power of 1. That's what makes this linear. If this were x to the second or x to the third, we would have a different behavior on a graph. It would not be a line. It might be a parabola. It might be like a squiggle. All right. So for this to be a line, x has to be x to the first. Okay. So from there, we have different behavior of lines. So if I have two lines, okay, if two lines have different slopes, they're going to intersect at some point on my coordinate plane. They have to. Okay. If two lines are parallel, this means they have the same slope. If two lines are parallel, like we see here, line 1 and line 2, these two lines are parallel, and I know that because of these tick marks. See it? I have 1 and 2 and 1 and 2 tick marks. These tick marks tell me that these two lines are parallel. If they're parallel, that means that they have the same slope automatically, and therefore they never intersect. Okay? Parallel lines never intersect. When I look at parallel lines, I think of railroad tracks. Okay, when you think of railroad tracks, they have to be parallel. Okay, which means they never intersect. If their slope is slightly off, right, then that means they would intersect, and you'd have a huge problem if a train were on those tracks, right? So parallel lines, I think railroad tracks, two straight lines that never intersect. Parallel. Okay. Then I'm going to come over to here, and I also could have perpendicular lines. Okay, so again, if my two lines have the same slope, then they're parallel. Perpendicular lines, okay, perpendicular lines tell me that when these two lines intersect, they form a 90-degree angle. Okay, so our coordinate plane at the point of origin, right, my x-axis and my y-axis form a perfect 90-degree angle. So the x and y-axis are perpendicular lines. Also, you can think of a compass, okay? You can think of a four-way stop. You can think of a plus sign or the cross, okay? All of these form a perpendicular line. This little mark here that forms like a square, okay? This mark here tells me that this is a 90-degree angle. When I have a 90-degree angle, I know that these two lines are perpendicular, okay? When they're perpendicular, their slopes are opposite reciprocals. So we're going to talk more about what an opposite reciprocal is. Okay, you learned about this when you when you divided fractions, right? You changed division to multiplication, and you made the second number, it's reciprocal, okay? Opposite reciprocal means you're also changing the sign. So for example, if I have positive 3 over 4, the opposite reciprocal to that would be what? Negative 4 over 3. Does that make sense? Okay, so again, we're going to be doing more work with this in a minute, but I just want you to copy this down. Okay, and again, the focus is on parallel lines, same slope, perpendicular lines, opposite reciprocals. Get my slide to switch. Here we go. Okay, on this slide, we're just talking about the difference between parallel lines and perpendicular lines. So for two lines to be parallel, again, they have the same slope. That's key. So if two distinct non-vertical lines are parallel, then they always have equal slopes. Okay, same slope, equal slope. If two lines have equal slopes, then they are parallel, automatically. So if I have two lines and I notice that they have the same slope, they're automatically going to be parallel. All vertical lines are parallel, right? They have undefined slopes, which would also be the same slope. So all vertical lines are parallel. Perpendicular lines. Two lines are perpendicular if their slopes are negative reciprocals, or the product of their slopes is -1. What that means is if you take the slopes of two lines and multiply them together, you would get -1 when you simplify it, okay? Because when you multiply opposite reciprocals, you're always going to get -1. Also, every vertical line is always perpendicular to every horizontal line. So if I have a vertical line and a horizontal line, so say my vertical line is x equals 3, my horizontal line might be y equals 100, okay? It doesn't matter how big it is. If it's horizontal and vertical, they're going to intersect and form a perfect 90-degree angle, and therefore they would be perpendicular. Okay, here we have an example of two lines on a graph. So I have line F and line G. So f of x equals what? 2x plus 3. And this line here is called g of x, which equals 2x minus 1. So what I want you to note here is that we're not looking at the y-intercept. See how I have -1 and I have +3, right? That doesn't even matter when we're talking about slope and we're talking about parallel and perpendicular lines. So when we're talking about parallel and perpendicular lines, the only thing we're going to focus on is the slope, which is the number before x. So when I look here, f of x equals 2x, right? My slope here is 2. And then when I come over to here, g of x equals 2x minus 1. My slope, again, is the number before x. That's my m, right? Y equals mx plus b. So the number before x is my slope. So here I have a slope of 2. G has a slope of 2. F has a slope of 2. So therefore, I can conclude that these lines are parallel lines because they have the same slope. So same slope equals parallel line. Parallel lines, plural. Same slopes equals parallel lines. Got it? Okay. In this example, all right, I want you to notice that this line here is called y equals -1/3 x plus 2. And then my line here is y equals 3x minus 4. Okay, I want to know, are these perpendicular lines? So this line here tells me that this is a 90-degree angle, so these should be perpendicular lines. To check that, I'm going to check to see whether or not these two slopes, when multiplied together, give me -1, or I could check to see if they're opposite reciprocals. So when I look here, I have -1/3. Guys, if I were to say what's the opposite reciprocal of -1/3, what would it be? So you're going to take this fraction and flip it, and that gives me 3/1, or 3. And then the opposite of negative is obviously what? Positive. So the opposite reciprocal to -1/3 is +3/1, or +3. When I come over to here, I have +3. So therefore, these two are both opposite reciprocals. Also, if I were to take 3 and put it over 1 and multiply it to -1/3, that would give me -3/3, which equals -1. Therefore, okay, no matter how you look at it, opposite reciprocal, or you multiply them together and it gives you -1, okay, I know that these are both perpendicular lines because they have opposite reciprocal slopes. Alright, here are some examples. If I have the slope of line 1 and slope of line 2, this is my number 1. So I want you to tell me, is this perpendicular or parallel? So if I have 9/11 and -11/9, right, for this to be, or neither is my other option, okay, for this to be perpendicular, you'd have to flip it and change the sign, which we do. 9/11 becomes 11/9, and my sign switched. So therefore, number 1, okay, is perpendicular. Number 2, I have 5/9, and I'm comparing that to 9/5. Unfortunately, these are reciprocals, but they're not opposite reciprocals. My sign stayed the same. So one of these would have to be negative, and one would have to be positive for this to be perpendicular. So my answer for this one, you guys, is neither. It's neither parallel nor perpendicular. Number 3, I have 8 and negative 8. Here, my sign switched, but I did not flip 8. So 8, how would I flip 8, right? If 8 were a fraction, it'd be 8 over 1. And then I'd flip it to make it what? Negative 1/8. So number 3 is neither as well. Number 4, I have a slope of 7 and a slope of 7. Same slope, these would be parallel lines. Number 5, once again, 5/9 and 9/5. These are reciprocals, but I didn't switch my sign. I have 2 positive slopes here. One of these would have to be negative for it to be perpendicular. Therefore, number 5 is neither. Number 6, I have 3/5 and negative 3/5. So here we changed the sign, but I forgot to flip, right, the fraction. So I have opposite, but I don't have a reciprocal here. So therefore, number 6 is neither. So there you have it. Those are my answers. Perpendicular, neither, neither, parallel, neither, neither. All right, my next set of slopes, my slope for line 1 has a slope of 10/11. My slope for line 2 is negative 11/10. These, you guys, are opposite reciprocals, okay? I took 10 over 11, I flipped it, and made it 11 over 10, and I switched the sign. So this would be perpendicular. Number 2 is also perpendicular. Again, if I take 5, I make it opposite, so it becomes negative, and then 5 over 1 becomes 1 over 5, right? These are opposite reciprocals, therefore they're perpendicular. Number 3, I have 5/6, and I have its reciprocal of 6/5. However, these two are not opposites. They're both positive. So therefore, number 3 is neither. It's neither parallel nor perpendicular. Number 4, I have 11 and negative 11. Okay, those are not the same slope. All right, one's positive, one's negative. Those are not the same. All right, they're not opposite reciprocals, so therefore neither. When I say neither, you guys, that means that they intersect, but they don't form a 90-degree angle, so they're not perpendicular. And they're not the same slope, so therefore they're not parallel. So for it to be neither, it means that there are 2 lines that intersect. They just don't form a 90-degree angle. Okay? Number 5, I have 7/8 and 7/8. Same slope, parallel lines. And for number 6, I have 3, and I have its reciprocal of 1/3. However, I didn't have a sign change here. These are both positive. Okay, therefore, this answer is neither. And those are my answers. Again, you guys, all we're doing in this section is just telling the difference between parallel lines and perpendicular lines by comparing slope. So I hope this video was helpful. I'll be doing a follow-up video to explain the workbook, so stay tuned.